Okay, let's start with this system of equations we're going to solve by using substitution. Okay, so I took these equations over here, 1 and 2, and I turned them into, I didn't change the first one, but I changed the second one into that. Okay, so I solved for y, and now what I can do is I can take y right here. I can take this, because this is what y equals, and I can plug it in right there. And now what will happen is I'll only have an equation in terms of x. Yeah, do you see that? All right, so I'm going to plug that in. Let's do it. So I'm going to rewrite this right here. Only I'm not going to place this y in there. I'm going to replace it. So I got 3x minus 4 times some quantity equals negative 15. That quantity that I'm going to plug in there is negative 5x minus 2. Okay, everybody comfortable with that? All right, now you just have to make sure that your algebra is solid. This is going to stay 3x, but when I distribute this negative 4 to these two terms, it'll become a positive 20x and a positive 8. Yeah? Pay attention to that negative being distributed. You might see it already. I see it. I think x is going to be negative 1, but I get 23x. And if I subtract 8 from both sides, it looks like I get negative 23x, or negative 23 on the other side. So it looks like x equals negative 1. Okay, so now what? Because I know half of it. How can I find y? Yes, sir, in the back, Sean. Yeah, and I'd use the easiest one right there. I'm going to plug a negative 1 in right there. So if I plug it in right there, I'd have y equals negative 5 times negative 1 minus 2. All right, let's make the connection here. This is a negative 1 right there. You can plug it into any of the equations you had at the very top, but some might be more work than others. So that would be what? Negative times negative is a positive 5 minus 2. It looks like I get 3. There's the spot where what happens. What happens at that spot, at that point? The lines cross. Yeah, they intersect at that point. Review. Let's do a quick review from Friday. We talked about 3 different special points of concurrency. One of them was the incenter. One of them was the circumcenter. And the third one, anybody remember it? Up in the air. No, starting with an O. It's kind of like the dentist. Orthocenter, yeah. Orthocenter. Okay, and the incenter was formed by the angle bisectors. The circumcenter was formed by the perpendicular bisectors. And the orthocenter was formed by the altitudes. All right, so today we're going to talk about the 4th point of concurrency, which is, it's called the centroid. Okay, so we're going to talk about this thing called the centroid. Right here. We're going to apply the centroid conjecture and identify the center of gravity of a triangle. So say you have a triangle and you want to balance it on one finger. Finding the centroid would be that center of balance, right? Or center of gravity. That's the centroid. Now, the previous 3 that we had talked about, right? 2 of them had practical applications. 1 of them didn't. You remember which one didn't have a practical application? Did not have a practical application. Yeah, orthocenter is doesn't have a practical application, but the other 2 do. Right? The incenter was equidistant from the 3 sides of the triangle, or we talked about roads or paths. Wow. Apparently roads are spelled roadas. I didn't do that on purpose. Or paths, right? And then over here, the circumcenter was equidistant from the three what? From three vertices. And what we said, like cities or towns, right? Or locations. We talked about high schools, right? We said, let's put a medical facility between, our high school and two other high schools. The 5K, no, the 5K was roads or paths, right? But if we had three different events going on at three separate locations and we wanted it to be equidistant, this medical facility to be equidistant from those three places, those three towns, cities, high schools, locations, we used the circumcenter.
That's like the big circle. That's so confusing.
Oh my gosh. ROTAs. We'll come up with a ROTAs formula later. Okay. Let's get started with the lesson. Okay, so just a quick review of vocabulary. The three angle bisectors of a triangle form what? We just talked about it. The incenter. Very good. Thank you. Which is equidistant from the triangle's sides and is the center of the... Okay, now this is the weird one, but here you go. Here's a triangle. The incenter is the center of the circle inside the triangle, right? That's called the inscribed circle. Inscribed. Okay? The perpendicular bisectors of a triangle create the what? Circumcenter. Okay, which is equidistant from the triangle's vertices, which is the same as like the corners, the angles, etc., and is the center of the circumscribed circle. Okay, so what that means is a triangle with the circle around it. Remember that? Right? Yeah, thank you. I'm very good at drawing triangles with circles around them. And then the altitudes, of course, like we know, they create the orthocenter. That's the orthocenter. So new today, the medians. What the heck is a median? What is a median other than the thing in the middle of the road?
I remember doing the range, the median. I'm guessing it's the middle.
The median goes from a vertex to the middle of the opposite side. Yep, pretty much. Goes from a vertex to the middle of the opposite side. So if I did that on all three corners, chong to fyong, that forms the centroid. I don't want that. I want that. There we go. Center, or the vertex to the center of the opposite side. That point right there, let's go happy face. That's the centroid. So if you go from vertex to the center of the opposite side, right, midpoint, on all three of the vertices, and you put your finger underneath that triangle, I don't care if it's the size of the school, as long as it won't crush you, it would be the center of balance. Yeah? Yeah? Isn't that?
But what would you use it for?
To balance something.
You're going to calculate really.
Yeah. It's the center of gravity, right? Don't you think maybe that's used in construction somewhere? Maybe. Okay. So the medians of the triangle, they form the centroid. There's our friend, centroid. I'm going to write with the radioactive hot dog. Centroid. That's the radioactive hot dog. Yeah, Wyatt. Go on. All right, so let's talk about the centroid for a moment. There's a couple of different things special about the centroid. Okay. What's cool is when you draw the centroid, right? What happens is that it splits up this point, this happy face right here, splits up each of the segments in a 2-to-1 ratio. So example, let me get the highlighter out. No, not that one. That's the one. Each of these purple segments is going to be twice as long as the rest of the segment, right? So if that green segment is 10, what is X going to be? 20. Yeah, so it basically doubles that. Okay, so if this purple segment right here is, let's say, 15, what would Y equal over here? 7.5, right? What it does is it splits it into 2-to-1 ratio. All right, 1/3, 2/3. All right, so let's look at an example on the next one. If I know that BC, this length right here, that length right there is 16. What does that make AC? 8. Well, and then of course AB, what would AB equal then? The sum of those two, right? So far, so good. Pretty basic, right? Take that, divide by 2. Sometimes I'm going to give you the shorter one, and someone's going to divide by 2 again. And you're going to be like, what? Wait a minute, what? Okay, example here. AC is 3. So if AC is 3, what is BC? 6. Good. So then AB has to be 9. No. How did I get 6? I took 3 and I doubled it.
So you always just double it?
You'll always double the short length to get the other length.
Oh, okay.
Yeah? Okay, what would I do with the short length to get the full length? Triple it. Right? How do I go from the short length to the full length of that? Yeah. Median, right? I'd triple it. Okay, let's look at another example here. Why don't you with a neighbor find AC and BC? Good. Okay, so let's see how you did with that. If I know that AB is 12, this distance right here is 12. What fraction of 12 is that distance? 1/3 of it, right? So this would have to equal 4, and therefore to get BC, I would double that and I'd get 8. So it looks like AC would be 4 units and BC would be 8 units. All right. Okay, basics of that. That should be good. Should be pretty solid now. Another property of the centroid, like we said, is that it's the center of gravity of a triangular region. So if you find the centroid by finding the point of intersection of the 3 medians, you've found that center of gravity. So what the heck? How would I do that? How would I find the center of gravity of this triangle? Well, here's A. Let's say I got my coordinate grid here. A would be left and down. Let's put A over here. B would be right and down. And C would be left and up. All right. So I got this triangle. How could I find the center of gravity? Well, it's a special property, you guys. The centroid, the point, is going to be the average of the x's, comma, the average of the y's. So let's do some math. What are my 3 x's? It looks like -5, 3, and -1. Let's add those up. So this centroid will be -5 plus 3 minus 1 over 3. What do we get there? Let's add them up first. -5, 3, and -1. I get -3. What do you get? Yeah? Okay, and then let's do the same thing for the y's. So -3, -5, 2. -3, -5, 2. -3, -5, 2. -3, -5 is -8. -8 and 2 is -6. -6 divided by 3. What would that reduce to? -1, comma, -2. Let's plot that and see where it is and see if it looks like it might be the center of gravity. If Mr. Ludd went and did his sketch relatively accurately. So -1, -2. Does that look like it's about the center balance? I don't think I sketched it well enough, right? But that would be technically that center of gravity of that triangle, right? Okay, that would be the centroid. And of course, then if you're an engineer of some sort and you're trying to balance a triangle on, you know, the top of a, I don't know. But if you were, that's what you would do. Right, Hans? Yeah. Hans, where are you from? Norway. You guys ever balance triangles on things? Yeah. On top of what? Unicorns? Okay. Thanks for that, Hans. All right. Like, subscribe, comment below. That's it for lesson 2. Tomorrow we'll be doing a review day and a quiz. Yeah? $19 GNC, 100